Hello, good afternoon. Thank you for giving us opportunity. My name is Zoran Lazarevic. I am CTO for Middle East and Africa and Ericsson. We're gonna look at, you're gonna see the slides now. We're gonna, agenda or topic for this session is 5G opportunity. And we're gonna look at how 5G can help us to save energy, to break the energy curve. Let me see some, is it like this? Yes. Let's start with first what is happening with 5G. How fast we are deploying 5G. This is the first 3 years of the 5G measurement from our partner. What you can see, we can see first that some of the first yellow dots are here in Middle East, in GCC. Actually, I think third network globally after US and Korea was network here in GCC in UAE. The second thing you see, it's really growing very fast. And I will come back to you. Actually, we measured how much faster 5G is deploying or adopted compared to 4G. And then finally, you can also see some of the biggest bars here, some of the best networks are actually here in the neighborhood, in Riyadh and also in UAE. So it is really adopting fast. This is from Ericsson Mobility Report. Ericsson, for over 10 years, we are collecting data from networks across the world, and then we are presenting information like this, how many subscriptions we have in each of the technology. And then also we make prediction what's going to happen in next 5 to 6 years. And this is what we expect. We expect that majority of the traffic by 2027 will be on 5G, 48%. 4G is having its peak this year, and then we're going to see slowing down and dominating by 5G in the period to come. I was mentioning that 5G is the fastest developing technology. And we was comparing to actually with 4G. What we are comparing here, we are comparing how long it took 4G to have first billion subscription. It took over 5 years, almost 6 years for 4G to reach this 1 billion subscription. In 5G, we're going to reach 1 billion subscription this year. So it's over 2 year faster deployment adoption of 5G compared to 4G. At 5G, everything was fast if you want. Standardization was very fast. Adoption was also very fast. And then final graph from Ericsson Mobility Report is showing that in telecom, in mobile industry, it's business as usual. In the sense, we have this exponential demand, exponential growth. Again, you see here, this is from 2015. Obviously, we have this much earlier from when we were starting 2010, when we start preparing mobility report. And you see this exponential growth in the data consumption. Obviously, there's no reason for us not to assume that this will continue, that we're going to continue having this exponential growth. So all of this looks really fantastic. We're having fast adoption, we have need, we have exponential growth of the data. Is there some challenges which we need to address? Well, yes, there is a challenge also. Challenge is $25 billion US, how much industry is spending on energy on mobile networks per year. And majority of this energy consumption, or this bill, is going for the radio networks. Radio networks is consuming 70 to 80% of the network. That's a challenge for every country. It's a big challenge in Jordan. And also what we saw, obviously with every technology, we are getting much better quality. We are getting better throughput. We are serving more customers. But also we see that we are consuming more and more energy. So with every generation, we see that data consumption is growing up. So is this sustainable? Shall we expect that with 5G, we're going to have the same trend? That's what we're calling breaking the energy curve. We believe no, that with 5G, the trend will be reversed. Of course, we're going to have much higher throughput. Of course, we're going to have much more customers. Of course, we're going to have much higher quality, but also we're going to have less energy consumption. And from where this is coming? It's coming from a couple of things. First thing is something which is actually built in standardization from 5G. This is this orange bars which I'm presenting here. What is this? This is a signal which base station is sending regardless if there is a traffic. Even if there is no traffic on any site, base station need to send some information to inform mobile phones, listen, this is the base station, you should log in, this information to collect, to be able to make that phone call or to serve the web. On the top you see that information which 5G base station is sending. And on the bottom you see 4G. So 4G need to send every 0.2 millisecond information, regardless if there is a traffic or no traffic. 5G is standardized in the way that it's sending every 20 milliseconds or every 10 milliseconds. So this is actually base which is giving us the chance to break energy curve with 5G. This is the most energy-aware technology built so far. What does it mean in reality? In reality, that means that yes, why this is important? And this is a busy slide, but let me guide it through this slide. What we see here on that blue line, this is daily traffic in one network. I mean, you have what we call peak hour, that hour there when it's majority of the traffic. That peak hour is usually 1 or 2 or maximum 3 hours per day. 3 o'clock in the afternoon, 4 o'clock in the morning, in the afternoon. But you also have this other period of day, 3 o'clock in the morning, 4 o'clock in the morning. Almost nobody is using the traffic. How we are designing our network? We are designing our network for the peak traffic. So we need to put all capacity to serve the customers for the peak traffic, which is only 1 or 2 hours per day. The remaining of the day, network is quite empty. So if you look in average, network is 20–30% utilized. So some 30% of the time we are using capacity. But if you look at the energy bill, it's almost constant. This is 4G. Regardless, is there high traffic or low traffic, if you look at the energy bill, if you speak with operators and ask him how much less your network is consuming in 3 o'clock in the morning compared to 3 o'clock in the afternoon, it's peak hour, they're going to say it's almost the same. And that is the result of those green bars which we were seeing from 4G, which is always transmitting signal and not allowing a network to save the energy. This is the base for 5G. So the main consumers, we were saying the radio network is the main consumer of energy in the mobile network. And the radio network, when we talk about radio network, we are talking about those two blue and red things. We are talking about the radio, which we are putting on the top of the tower. And we are talking about something which we call digital basebands, like small brain for processor for that base station. This is the main consumers in the radio network. And the biggest one is that red one, radio itself. So that equipment which you're putting on top of the tower. This is how it looks like in 4G. Regardless of you having traffic or you're not having traffic on the site, it will consume a lot of energy. Of course, it goes down a little bit when there's less traffic, but still it's consuming the loss. That's a lot. That's what we're addressing with 5G. With utilizing the possibility which standardization is allowing us, building radios, building hardware to take advantage of it, implementing some clever features like microsleep TX. That's the main thing. Main thing is to completely switch off the radio if there is no traffic. And because we have this non-frequent signals, we can switch off the radio. We can switch off the radio when there's no, and that's how we are saving. So to summarize, yes, absolutely, it's possible to break energy curve with 5G. 5G will help us not only to have much better throughput, much lower latency, to provide much better customer to our customers, quality to our customers, but also to save the energy curve. And I want to say also at the end, it's not only one thing. It's not only hardware and software. This is most important. We are very proud, for instance, that we have our, you see there, Ericsson Silicon, our chipset, which we are putting in the radio, which is allowing us to have these very advanced features to estimate when the radio can be switched off, how we can save the energy. But it's not only that. It's actually a holistic approach. We need to address very important also infrastructure. that AC, which is cooling that equipment which is using, or maybe sometimes if we have generators. So there is a whole site infrastructure which we need to address using AI, machine learning, to understand when we can save the energy, how we can save the energy. With that approach, we can definitely break the energy curve. Thank you very much.